Welcome to Developer Ramp Up, the channel dedicated to anybody who wishes to become a software developer. Today we'll talk about lists in C# and more specifically how to sort them. This topic is very important because lists are very common, and as a software developer you will work with lists almost every day. And that's why we have to look how to sort lists in C#. Sorting is not necessarily very hard. In fact, it could be very easy if you want to sort lists of strings or integers and so on, because we have a default sort method on the list and then we can sort the items. However, things can get a little bit more complicated once we want to sort lists of our custom objects or custom types, let's say. And in this case, we have to think about different scenarios that are also available, for example, for strings. Because if you use the sort method, the default sort method on a list of strings, it will sort the list alphabetically. However, there might be scenarios where you want to sort the list according to string length and not alphabetically. And in this case, you would have to implement some custom logic to the sorting of this list of string. And the processes that you would use are exactly the same that you would use in order to implement sorting on a list of custom types. So let's look a little bit on how sorting works in C#. But before we can do that, let's create a list of string. Okay, and let's call it names. And it will be equal to a new list of string. Okay, and now we have the list, but the list is empty, so let's add some names to the list. We can use for that the default add method, which is very easy and straightforward. Let's add Dan as a first name. Let's add also a second name, and let's in this case take Zach. Let's add a third name. And the third name in this case would be Jason, let's say. And last but not least, let's add a new name, and this would be Christina in this case. Now we have a list, and the next thing we can do is names.sort, and this will sort the list. And of course afterwards we can use a for each loop of var name in names, and for each name we want to print it to the console, so console write line name. And before we can give it a try, one last thing I want to do is also add a console read line. If I don't add console read line, when we run the project, it will do the sorting, it will display the list, but then it will close. And we won't have time to see exactly the output. But by providing this console read line, the console will stay open. So let's run this program right now. And as you can see, the list is now sorted, and it is sorted alphabetically. So that's good. As we said, for strings, the default sort method sorts the list alphabetically. Now, our scenario was that we wanted to do a custom sorting on a list of strings that would sort all the elements based on string length. So we could do that, but before we can jump into the code, let's see the definition of list of T, because we have a list of string in this case. And we see here that we have the sort method that we already used, but we also see that there are some overloads for this method. For example, the first overload that we see here takes a comparison of T delegate. Now, delegates is a total separate topic that we'll discuss on Developer Ramp Up, but for now, note only that delegates are nothing else than simple methods that can be passed as arguments to another method. So we have the sort method, and then we would have a delegate that we can pass to this sort method. And we look exactly how this comparison of T is implemented and how we can do that. Now, the next overload is something that we won't look into this tutorial because it's a little bit more complicated. But what this sort method does, it takes an integer, which is the index, so where exactly to start the sorting, the count, so how many elements to sort, and an IComparer of t, which is a custom comparer. So this means that if we use this method, we can specify, or we can choose to sort only of a subset of elements from the entire list and not the entire list itself. And the last overload that we also take a deeper look today is this IComparer of t. This means that we have to provide a custom comparer. So here we just provide a delegate, but here we have to provide a custom comparer. And we will see exactly in the code how these two different options look like and how they are different and things that are maybe similar. But let's get back to the program right now. So as we said, we want to perform a sort according to string length and using this comparison of t delegate. What we will have to do is then of course run this sort, and as a delegate we will provide in this case a lambda expression. Now lambda expression is a total different topic that we will cover on developer ramp up, but for now just know that a lambda expression is just an anonymous method, and as we said earlier, a delegate is nothing else than a method that is passed as an argument into another method. So that's why we use a lambda expression here. The important thing here to note is that these variable names x and y are not important. You could have chosen a and b, c and h, and so on, so it's really not important. Any letter or symbol would make it. However, what is important is that names is a list of string as we have specified it. And what this means is that those two variables are assumed to be strings. And that's why we have custom properties and methods on them that are specific to strings. And for instance, on x we can take the length of x and then another compare to method which is built in to C#, and we can provide here y.length. And what this lambda method will do, it will compare two strings based on the string length. So exactly the thing that we would also want it to implement. And once again, we can use a for each loop var name in names and console write line. Okay, something went wrong here. Okay, console write line name. Okay. And if you run the program, normally we would expect that we would have two different sorted outputs. And in fact, yes, we have. And this is the first one, which is the one that is sorted alphabetically. And you see that the second output is the list sorted based on string length. So this worked, and it's proved to be great. Now let's go to the final step for this tutorial. And we said that we want to implement the sort comparison of t, and we want to implement the custom IComparer, because the custom IComparer is something that we could use on our own objects. And let's then go back to the code and let's comment out this line of code here. And just to make a short check, if we run right now the program, you will see that we will have two outputs, but both will be sorted alphabetically because we sorted the list only once with the default sort method, and this default sort method would sort it alphabetically. Now I have implemented also a custom comparer which I called NameComparer. So therefore I created a new class that that I have called NameComparer, and very important, it inherits from IComparer of string. And this makes a class to be a custom comparer. Then of course you have to implement the compare method, which we have done here, and we took several things into consideration. For example, what happens if x is null or y is null. In this case they are equal, but for example if y is not null, then of course we y should be bigger than x, and so on. But what I wanted to show you is that in the end, when we do the sorting itself, after we have taken into consideration all scenarios where x and y could be null. What we have implemented is exactly the same thing that we have used also when implementing the comparison of t-delegate. So we have used x as a string, then length compared to, and y length. And that's basically how this custom comparer works for strings. Now, if we want to implement it right now, this would be also very easy, but in order to do that, we have to create a new instance of a name comparer, and let's call it NC, and this would be a new name comparer. Okay, and then very easy, we could call names.sort, and instead of letting this method blank to use the default comparer, and also we will not use the comparison of t-delegate, we will simply provide the instance of our custom comparer. And in fact, if we now run our program, we will see that we will have a similar output to what we had previously. In fact, yes, this is the list sorted alphabetically, and this is the list sorted based on string length. So the name comparer works just fine. Now, the difference is that here, for instance, and let's right now comment out this code because we won't use it anymore to run the program. Here we implemented the comparison of t-delegate using the sort method or in the sort method, while the second time we implemented our custom comparer, which is a total separate class that inherits from IComparer of string. Let's for instance assume that you would have your own class which is called employees, and you want to create a list of employees. Now in that case, of course, you would create a list of employees, not a list of string. And also in that case, when you write your comparer for that type of list, you would implement or inherit from IComparer of employee, not IComparer of string. And here in the compare method of the custom comparer, you could really write your own logic in order to implement comparison between employees. So if we want to sort them, which employee should be or should come before the others, and so on. And this is how you would implement sorting in lists of your own types. Now this is only an introductory tutorial, and we will surely come back to this topic a little bit later to go a little bit more in depth about how sorting works, maybe also using the last sort method, which takes the index, the count, and also a custom IComparer. And we will also see exactly how we can implement logic in a custom comparer that we could use for employees or for any other class that we would write. Thank you very much for watching. For now, if you enjoyed this video, don't forget to push the subscribe button. If you know people that might be interested in this topic, feel free to share this video on your social networks. And until the next time, I wish you the very best.